All right, so today is the last lesson in 7-5. Now, you have a test on here on Wednesday, so we're going to review tomorrow in class. Guys, the number one error that people have been struggling with has been really not doing the math behind it as much per se, but making sure that you guys are taking the time to memorize. This is one of those things that's so mean about geometry. It's like a biology or an English class. You have to know the rules. You just have to memorize the rules. In last chapter, you guys didn't memorize the rules until the test, and then you did so much better. So the same type of ideas, you have to know the rules of like how to prove triangles similar. What is a similarity ratio? What's the definition of similar polygons? All those things matter. So today we're going to do one that's actually, it's a science lesson basically. We're doing what's called indirect measurement. So we're going to be actually just doing word problems a lot. So what is indirect measurement? Well, indirect measurement is any method that uses formulas, similar figures. Actually, we got similar here. Similar figures and or proportions. Oh, go figure. We're using proportions of all things to measure an object. So I'm going to try to figure out to do this. This is what surveyors do a lot. This is a lot of times what construction crews have to do. Think about it. Are you really going to go to the top of the Willis or Sears Tower, whatever you want to call it, and drop a measure tape to the ground to measure it? Seriously? No. A person actually stands on the ground and they use indirect measurement to figure out how tall it is. And they'll get it very accurately done. So that's the type of stuff that they use. So here's a few things you need to know. You are going to be doing a lot of stuff, please forgive me, in feet or inches, centimeters or meters or whatever. In order to do this well, you need to make sure that you calculate everything in just inches or everything in feet. So like when you see combined stuff like this, 38 feet 4 inches, throw that out. Like you don't want to use that. You want to either use all inches or all feet. Now, I always normally change everything to the smaller measurement because then you don't have to worry about decimals or anything like that or fractions. But here's the type of problem that you do. It's called indirect measurement problem. It says Tyler wants to find the height of a telephone pole. He measured the pole's shadow and his own shadow and then made a diagram. What is the height of the pole? Now, obviously, the things that are being assumed, is he going to be perpendicular to the ground? Right? Is a telephone pole supposed to be perpendicular to the ground? Okay, in the real world, have you ever driven around and seen a crooked telephone pole? Let's just go there. Yes, so understand this telephone pole that he's using has to be perpendicular to the ground. But if you ever driven around, they lean sometimes. But let's convert everything that we need to do real quick. So make sure your calculators are out real quick, guys. This is where it's very helpful. I need to convert 7 feet 8 inches to all inches. So I'm going to go 7 times what? 12. All right, so what's 7 times 12 plus 8? Should be 92 inches, I think. What's 5 feet 9 inches? Now, guys, 5 feet, this is very important because this was like a big touchstone for most people's growing up. What's 5 times 12? Plus 9. So I got 69 inches. So I have 38 feet 4 inches is the length of the pole shadow. Please do that one for me real quick. 38 times 12 plus 4. 460 inches. Now do I have everything in inches so I can go ahead and calculate it real fast? Now I want to make sure, and this is where I want to start pushing you guys on, make sure you put things that are similar. Go to the sides that go together. A lot of you like, ooh, I'm just going to go 92 to 69 as 460 is to h. Stop doing that because you don't know how to do similarity ratios now as a result. Which sides correspond? Well, if I'm going from small to big, do you guys agree with me? The height of the person is going to go to the height of the pole. Because they're going to be, so I can go 69 is to h as, well, we're going to go the small one again. 92 inches is for the shadow as 460 is to the shadow. This is when you're going to cross multiply. I get 92 times h is equal to whatever 69 times 460. Do you see where I want you to have the calculators out right now? This is not numbers I memorize in my head. All right, someone shout it out once you got 69 times 460. I mean, that's just what everyone has as a number in their head. All right, so 31,740 inches. Divide both sides by 92. So the height is 300 and I think it's 45 inches. All right, convert that to feet. Convert that to feet. What is the easiest way of converting that to the feet? Isn't that going to end up being using your fraction key on your calculator? I'm going to take 345 and put that over what number? 12. After you do that, can you change it to a mixed number? A mixed number. Did you guys change it to a mixed number? What did you get? 28 what? What did you guys get? 28 feet. And what was the 3/4? So how many inches is that? 3/4 is how many inches? No, 3/4 of 12, 9 inches. 28 feet, 9 inches. Or could you say 28 3/4 of a foot? Would that also work? You see, like, I'm just trying to keep it like what they originally had, but either one of these is going to be technically correct. Doesn't mean I'm going to always put both answers down on the answer key. That's going to be up for you guys to convert if you need to. All right. Why do they do these flagpole examples? I don't know, but every math book I've ever taught from has always used flagpole examples every stinking time. So just know these are how they're going to do it. All right. So they just do. So just learn how to do flagpole problems. All right. But it says here, a student who is 5 feet 6 inches tall measures a shadow to find the length of LM of the flagpole. So I want to figure out how tall the flagpole is. Isn't this just doing the exact same thing that we just did, guys? All right. So let's quickly convert these. Well, 5 feet we know is 60 inches. 5 feet 6 inches tall is going to be your 66 inches. 14 feet 2 inches is how many total inches is that going to be? 170. Can I set up a proportion now to solve for this? All right, guys, someone give me the proportion. What are we going to do? Go for it, Alan.
66 inches over each.
Perfect. I like that. And if I really wanted to, could I go 66 H equals 6 over 17? Can I simplify that out if I wanted to? Yep. All right, guys, cross multiply now. So I get 6 times the height equals 66 times 17. Go ahead and divide both sides by 6. I think it should be 187, but double check me on this. Did you guys get 187 inches? All right, quick for me, change that to feet. Do like what we did before, go 187 over 12. Change that into a mixed number for me. What'd you guys get? Or are you in the process? It's 15 feet something. What'd you guys get? Yep, 15 feet 7 inches. This time, did you get 7 over 12 in your mixed number? Yeah, that's good. Thank you, mixed number. All right, so it's going to be 15 feet 7 inches. That is the height of the pole. What do you guys think? Pretty easy? All right, guys, have you done? All right, sophomores, you've done this, so you can. Yeah, the next one's actually a very physics example. It's using.
Oh, I have the physics test.
All right, well, hopefully. Ouch. You might want to study that for it. All right, here's an example of indirect measurement that you might have actually talked about in physics. It says Natasha places a mirror on the ground 24 feet from the base of an oak. She walks backward until she sees the top of the tree in the middle of the mirror. At that point, Natasha's eyes are 5.5 feet above the ground and her feet are 4 feet from the image in the mirror. Find the height of the oak tree. All right, what is she using in order to see this? Isn't she using the angle of reflection? And so what do you know about your angle of reflection? And I can't remember if it's refraction or reflection, so don't let my physics help you at all in here, because I won't know the terms. But as when you're looking at the mirror, the reflection of the tree to the mirror and then back up is going to be exactly the same angle. Then what do we assume about the person? Well, they're perpendicular to the ground, and the tree is perpendicular to the ground. If I have 2 pairs of congruent angles, how are those triangles congruent? A similarity, right? So angle. All right, guys, did you hear what I just said? If you have any 2 pairs of angles congruent in a triangle, they're what? Similar by a similarity. Some of you kind of just threw that out the window when you were taking your quiz the other day. You had congruent angles and you just didn't use them. So make sure you have that. But as a result, I now have these similar triangles. Can I set up a proportion real quick to solve for the height of the tree? Yeah, what's going to be my proportion? 5.5 to what, guys?
Wait, no.
No, 5.5 is to x. Yep, height to height, right? Is the same as the distance on the ground to the distance on the ground, to the mirror. Again, cross multiply when you're doing this. What do we get here? We get 4x is equal to 24 times 5.5, which is the same thing as 4x is equal to 132. What are you going to get for your answer, scholars? Did you guys get 33 feet? All right, here's the other thing. Notice with these, a lot of labels you have to keep track of. Pretty simple stuff. All right, it's just using word problems with this. All right, scale drawings. Okay, I'm just telling you right now, I'm not making you draw anything to scale. I thought about doing that, and then I'm like, you know what? They've done this before. We're just going to talk about how you set up the proportion to do it. Sound fair? So remember, a scale drawing is just an object, represents an object or smaller or larger than its actual size. So when you're doing it for drawings, we call it the scale, or we call it the scale factor when you're working with it. Really, that scale or scale factor, isn't that really the similarity ratio between my two figures? So really, when you talk about scale or scale factor, you're really talking about the similarity ratio. So remember, it's the ratio of any length of the drawing to the corresponding actual length. So on a map, a scale of 1 centimeter to 1,500 meters is 1 centimeter on the map represents an actual distance of 1,500 meters. I mean, you guys are like, I don't need a map anymore. I have GPS, Gregerson. Yes, and have you ever noticed your GPS can lead you astray? It does about every third time if you're not careful, because if you punch it in wrong or if there's traffic, it's just bad. But anyway, so the idea of a map. All right, I'm using a Wisconsin example. Do not hurt me. I'm not using a Packer one at least, okay? All right. But with this one, it says on a Wisconsin map, Kristen measured a distance of 11 inches from Madison to Wausau. The scale of this map is 1 inch to 13 miles. What is the actual distance between Madison and Wausau to the nearest mile? All right, so this is, I'm giving you permission to round, correct? So with this one, this is when you might want to keep labels so you remember what you're labeling. So I got 1 inch is to 13 miles as, well, what did she measure? Did she measure the map? Or is she measuring the actual distance? Well, the map. So isn't that the 11 inches going to be on top? And I want to figure out the actual distance between the two. So I'm going to call D for distance. Again, just like any proportion we were doing, we're going to use our cross products and multiply. So I got 1 inch times the distance equals 13 miles times 11 inches. All right, I'm going to divide by 1 inch. Now, why did I keep the labels in? So you know what your label is going to be in the factor later at the end. Because look here, what happens to my inches? They simplify out, correct? My labels can even go away. And if that's the case, my distance is just what's 13 times 11. Someone double check me. Is that 143? Okay. So it's 143 miles is the distance between Madison and Wausau, Wisconsin. Good stuff. Yes, sir. When it's 1 like that, it's pretty easy. But yeah, remember the scale's not always 1 to that. And here's the thing. I would always get in the habit of doing the proportion though. Because that will always work. Because if you do bad math, otherwise this will catch you. It'll catch you sooner. But good setup earlier. All right, let's keep going. All right, I gave you 2 triangles. All right, with the person next to you. So Jenna, that means you need to go behind the other lovely ladies. Or actually, why don't you come over here, JD, and we can work with Jenna real quick. All right, with the people next to you, answer the following questions. I am not going to give you very long. Let's just say I'm going to give you about 8 minutes to answer the 5 questions. If we do it quicker, that's great. All right, most of you guys, I went through and filled in through 1 through 3. It says, are triangle ABC and DEF similar? If so, why? A lot of you said all sides are proportional, but what theorem approves that? Side, side, side similarity. So yes, because of side, side, side similarity. And I showed my ratios were all the same, right? Because if one of them messed up, they weren't going to be similar. Then I asked, what's the similarity ratio of triangle ABC to DEF? A lot of people really missed this on the quiz, which was supposed to be a very simple question. A similarity ratio is just a ratio of the corresponding sides. Guys, I will always either give you the similarity ratio or you have a pair of corresponding sides that you know. So you could have picked any of those. So I just said A, B, D, D, E in this case. And we know it reduces down to 1/2. So the similarity ratio is always 1 to 2 in this case. From the smaller one to the bigger one. If I asked you from the bigger to the smaller, it'd be 2 to 1, right? So keep that in mind. Then I asked you to find the perimeters. So I found the perimeter of triangle ABC to be 12 units, the perimeter of triangle DEF to be 24. And then the ratio of the perimeters, again, it says smaller triangle to bigger triangle. So that's 12 to 24. It's 1/2. So far, anything earth-shattering? No. So then it says compare the similarity ratio and the perimeter ratio of the two figures. Well, what do we know? The similarity ratio is 1/2. The ratio of the perimeter, it says perimeter ratio. I call it ratio of perimeters. Doesn't really matter. So if you ever see RP, that's what it means. I get to be 1/2. What is it? They're what? They're equal. Why? Why would that make sense? Besides the math doesn't lie. Yeah, it's still linear length, right? Isn't perimeter just adding up the sides? So I'm really talking about a linear measurement. So if my linear measurements already are 1 to 2, what's it going to be different when I just add all the sides together? Isn't it still going to have the same ratio? So yeah, so your similarity ratio and ratio of perimeters are always going to be the same. That will save a lot of work on today's homework. So just keep that in mind, guys. Good job. All right, now look at the next one. It says, all right, the area of triangle ABC is 6 square centimeters, and the area of triangle DEF is 24 square centimeters. Now, we could do 1/2 base times height and calculate it, but we haven't even talked about area yet, so I did all the hard work for you. But it says, what is the ratio of the area? And I guess I'm going to use, guess what? RA to represent ratio of area. I know you guys are very overwhelmed by this, right? All right. It from the two triangles, so I'm going to go 6 is to 24, correct? What does that reduce down to? 1/4. Now it says, is there any relationship to the similarity ratio? Anna, what do you think? Square. Thank you very much. How many of you said, well, it's just half of it? Anyone say 1/2? Okay, that's not a bad idea, but it's actually a little more technical. The numbers just worked out this way. The ratio of the area is really your similarity ratio squared. So it's 1/2 times 1/2. 1/4. Now, that's the really cool thing about this. So it's just the ratio of the area is my similarity ratio squared. Now think about this for a moment. Similarity ratio is linear. Ratio of area is two-dimensional. How do we label area, guys? Units squared, right? We actually say squared units is how you read it. But yeah, so all I'm doing to my similarity ratio is I'm taking my units and I'm doing what to it? Isn't that kind of cool? All right, so basically you guys just found out your next theorem. The proportional perimeters and areas theorem. So what it does is it actually saves me time from actually having to calculate area and perimeter anymore. I can just set up proportions as long as I know the figures are similar. So first of all, the key thing is they have to be what to each other? Similar, okay? So if two figures are similar and have the similarity ratio, and we're just going to be very generic, A to B, then the ratio of their perimeters is A to B, and the ratio of their areas is A squared to B squared. So really, everything's going to be based off of the similarity ratio. Now, what if I give you the ratio of area? Can I work backwards to find the similarity ratio? Instead of squaring it, you're going to take what? Oh, sound familiar? Another reason why we did radicals before we did this? Go figure, right? So we can take it either way. So let's go through this real quick. I love this because I think this makes so much sense. So for each pair of similar figures, find the ratio of the perimeters and the ratio of areas. Now again, just so we're all on the same page, when I do this, I go RP for ratio of perimeters, and I just go ratio of areas, I use RA, just so I don't have to write it down every single time the long way. That's my abbreviations, no one else's. All right, always ask yourself this question, what do you know? Guys, what do I know about those two figures? I know sides, correct? So is that going to be my similarity ratio? So I'm given similarity ratio, and I'm going to go left to right, 4 to 5. Because you're given similarity ratio, guys, what do you know about your ratio of perimeter? What's it going to be? Is that just 4 to 5 as well? Because similarity ratio and ratio of perimeter are the same. Isn't that what our notes say? Yeah, they're exactly the same. Now, how am I going to get my ratio of area? What do I have to do? I have to square it. I have to go 4/5 squared. Now, you can rewrite that as 4 squared over 5 squared if you need to. All right, guys, what does that come out to? 4 squared over 25. There's your ratio of area. Easy schmeezy? Yeah, it's meant to be that nice. It really is. All right, next one. Guys, what's my similarity ratio for those two triangles? Make sure you matchy-matchy. 3/5. If we go from smaller one to larger one, my similarity ratio is 3/5. What's going to be your ratio of perimeter? 3/5. See how easy this is. What's the ratio of area? 3/5 squared, which is, gotta make sure my equal sign works here. 9/25. I know, that easy. Now, be careful. You have to always know where your starting ratio is. You're going to be given one of these three. You just have to be able to go to the other ones. So here it says, find the similarity ratio and the ratio of the perimeters of each pair of similar figures. I have two regular hexagons with the areas of 8 square inches and 32 square inches. So what am I given here? I'm given the fact they're similar, but I'm given what? Area, similarity ratio, or perimeter? Area. So can I write my ratio of areas? So my ratio of areas is going to be 8:32. Now, the number one error people make on this is not to simplify their fractions. Everyone listen to me. If you don't simplify your fractions, you make yourself go through a lot more work than you have to. If I simplify this, do you guys agree with me? That's just 1/4. So my ratio of areas is 1/4. Now, I'm going to work backwards and always find my similarity ratio next. Because to find the similarity ratio, isn't that really square root of the ratio of areas? So let's actually calculate. So what's the square root of 1/4? Well, I'm going to rewrite that square root of 1 over the square root of 4, which is 1. The square root of 4 is what? Yeah, remember we're going to the smaller version, right? So we're going from area to side. So it'll be 1/2. So my similarity ratio is 1/2. Guys, what's the ratio of my perimeter then? Yeah, it's 1/2 because it's the same as my similarity ratio. The nice thing about ratio of perimeter and similarity ratio, they're exactly the same thing. That's the best part because they're both linear measurements. All right, now I'm talking about circles. Gregerson, you're talking about circles. We haven't talked about it. Guess what? Circles are very easy to get similar, okay? You only ever have to compare their radii, all right? You always have a similarity ratio there. But I have ratio of areas, once again, are given to us. And I'm going to go from a larger one to smaller one. I always go left to right when I read these. So I go 128 pi over 18 pi. All right, guys, what simplifies out? Can the pi's go away? Yeah, they divide out. And then we keep simplifying it. And I end up getting 64/9 is my ratio of areas. Because that's what I'm given with, so I can actually get my ratio of it. Now can I take the time and change it to my similarity ratio? Yeah, I know my similarity ratio is just square rooting, right, my ratio of area. So can I go the square root of 64 over the square root of 9? Just make sure you do it to both parts. What's the square of 64? The square root of 9? 3. There's your similarity ratio. What's your ratio of perimeter? 8/3. Guys, isn't this just made kind of easy? Probably after what we've been doing, this is almost too easy for you guys. So remember, similarity ratio, ratio of perimeters are equal. The ratio of area is the square of our similarity ratio. All right, now let's actually do some math that this works with. All right, and you'll have a lot of problems like this. It might not be perfectly worded the same way as this, but the setup is the same. It says, given the fact you have triangle LMN is similar to triangle QRT, find the perimeter P and the area A of triangle QRS. You have to ask yourself, what do you know? Well, notice I don't give a lot of information for those two triangles, but I do know one huge thing. They're similar. So I also know that they were given a pair of sides for each one of those. Can't I get a similarity ratio then? So really, aren't I given the similarity ratio? So my similarity ratio is going to be 13 to 9.1. Now I'm asking though for ratio, I want to know perimeter and I want to know area. So if I want to find perimeter, shouldn't I use ratio of perimeters? But what do I know about my ratio of perimeter? It's the same as my similarity ratio, right? So the nice thing is we know this is always true. Ratio of perimeter is equal to my similarity ratio. So shouldn't I be able to set up a proportion? Basically, I'm looking for the perimeter of the smaller triangle and the area of the smaller triangle. Well, let's set it up. I know 13 is to 9.1 is same as the perimeter of the larger one to the perimeter of the smaller one. So I'm just going to call it P. Now can I just use a proportion? Yeah, cross multiply. So I get 13 times P equals 9.1 times 36. Someone quick do this on your calculator. Double check me, but I think this is it. Is that right? Is it 327.6? All right, divide by 13. What are you going to get for your perimeter? Remember, this is really, I should say this, the perimeter of triangle QRS. Maybe that should be an S here. Ah, typo. All right. What's the perimeter of QRS? What'd you guys get? Did you guys get 25.2 centimeters? I hope that was a yes, right? Well, was there a decimal to start with? Yes. And notice I only went to the 10th, though, because there's one decimal there. If in doubt, you can always convert it to fractions. All right. With this one, I still need to find the ratio of area, but I need to remember the ratio of area is just your similarity ratio, what? Squared. So can I set up a proportion like this? For ratio of area, isn't that going to be 13 squared is to 9.1 squared? Now, guys, look how awful this looks like. That's 169 over 82.81. Ew. All right. If you want to put the squared symbols in there instead, that's fine. But I'm going to set up a proportion the same way. 169 is to 82.81 as, oh, I don't know why this did this again, but oh well. As, what do we got here? The area of the larger one, which is 60. That doesn't look right, does it? Like, I have a 169, you have a 60 over here. Trust me, the math works out. Over the area of the smaller one. I don't know why this is doing this. Let's see if I can go to drive there. All right. Cross multiply, 169 times A equals 60 times 82.81. Keep solving, guys. This is where the math is so much fun. Or actually, your calculator is so much fun more than that. Notice it works out really nice, even though it looks ugly. What's the area of that? All right, so I got 29 point, I got 4. Did you guys get 0.4? 4 square centimeters. Look at this. But doesn't that make sense? It's a smaller triangle, so should it have a smaller area? So kind of logically it works. But that's really the basics behind this, guys. It's not meant to be really hard. Look at the next one. How about you guys do it? All right, I'm gonna let you guys do it. See if you can set it up. So I made sure when I marked this, I'm just gonna make sure that we all get the same thing here. But did you guys all just sit there and at least pulled out the similarity ratio, correct? So you have your similarity ratio. Notice I just sat there and reminded myself, this is not something you have to do, but ratio of perimeter and similarity ratio are equal. So if I'm looking for the perimeter, I set up my proportion so it's going from the smaller triangle to the larger triangle. So 6.5 is to 13. As the perimeter of the smaller one goes to the perimeter of the larger one. So when you guys cross multiplied and you were working with this, I'm sure you got your numbers. What was it? 154. Wait, I can't even write my stuff down here right. Times 6.5. What did you get the perimeter to be? Do you guys get 27 inches even, I think? All right, so the perimeter of the smaller triangle, ABC, is 27 inches. Well, that makes sense because it's smaller than the perimeter of the bigger one, right? So at least it logically makes sense. So then when you're talking about your ratio of your area, remember, it's just your similarity ratio squared. So you got to square it, guys. What is going to be 6.5 over 13 squared? Remember, you square both the numerator and the denominator. You should have gotten 42.25 is to like 169. So that's your ratio of your areas. So I should still be able to set up my proportion. 42.25 is to 169 is the same as the area of the smaller one to the area of the larger one, which is 126. So then you just do your normal cross multiplying. If I actually write down what I want to do here. So I get 126 times 42.25. And if you solve for the area, what do you guys get? Did you get 31 point something? Did you get 31.5 even, I think? Yeah, 31.5 square inches. And again, let's double check to see if that's logical. Yeah, the area of the larger one's 126. We should have a smaller area for the smaller one. That's 31.5. What do you guys think? Doable? As long as you set up your proportions. Guys, I need to see work. Show me your cross multiplying and stuff, because that's a huge thing, your original setup. Otherwise, that's it for today. This is the end. So what's my suggestion for you? Tonight, I would start working on your review for the test. It's portfolio or test review again, just like the last test. It's in the test review section on the modules. Test is Wednesday. Yep. On block. All right, are we good? All right, awesome.